For this next one, we're going to be doing some energies of, these next two, we're going to do energies of photons. So here we're getting the energy of the photon, and we're given this wavelength. Now, what equation do we use? Don't worry, I'll give it to you. You just got to be able to recognize it. We know the energy of the photon is h times frequency, or energy of the photon is h times, because frequency here, if you go back up, is speed of light over lambda. So pick the one that we need. We're given wavelength, so let's use this equation. All right, so here we need Planck's constant. H is Planck's constant. I'll give that to you. 6.626 times 10 to the negative 34 joule seconds. Speed of light, 3 times 10 to the 8th meters per second. Now wavelength, here we're doing nanometers and meters. We got to deal with that conversion. 1 meter is 10 to the 9th nanometers. So that's the conversion you need to know. And 503 nanometers is what we're given. And we're left with nothing but joules. Okay. So let's see if I do. So that makes things easy when you have these programmed in. It just saves you a little bit of time. Times 10 to the 9th. And now we just need to divide by 503. So we should get really, really small numbers because we're talking about one photon. That is a very small amount. 3.95, 10 to the negative 19, put the units on it for joules. Next one, energy of a photon, only this time we're given frequency. So let's use energy equals h frequency. 6.626 times 10 to the negative 34 joule seconds. We multiply by frequency. Remember, frequency is the inverse unit. So that means this many, so the prefix goes with the number per second. So for hertz, you just put seconds in the bottom. So let's write our number, 835.6. Capital M stands for mega. Mega means million, so just put times 10 to the 6th. There's no unit on that because the unit goes in the bottom to cancel it out. Final unit of energy should be joules, and it is. So don't make it more complicated than necessary. Okay, so here we just need Planck's constant times 835.6 times 10 to the 6th. Okay, so 5.54 times 10 to the negative 25 joules. All right, now let's do one more that has to do with energy of the photon. Here we're given the wavelength and we're told how much energy it has, and we want to know the number of photons. So this is going to be a two-part calculation. So this is the energy of the pulse. So this is all the photons. Why don't we start with, let's find the energy of one photon. We can do that first. So energy of one photon. Here we're given wavelength, so let's use this equation first. So here, write out the numbers, even though I'll give them to you. Planck's constant, 3 times 10 to the 8th meters per second speed of light. We need to convert to nanometers. A billion, that's 10 to the 9th. Okay, cancel these out as I go like I should be. 532 nanometers. All right. Now, what we can also do is notice this pulse unit is given in millijoules. and I'm going to get an answer in joules. So I'm going to go ahead and convert this to millijoules while I'm on here and say, 1 joule is 1,000 millijoules, not milliliters, joules. That'll just make the second part of the equation go a little bit faster. But you don't have to do that. You can convert that in a different way or at a different time if you want to. Times, get this where you actually see it. There we go. 10 to the 9th times 1,000. Whoa. 10 to the 9th times 1,000. And let's divide by 532. So 3.736. 3.736 times 10 to the negative 16th millijoules, and that's per photon. So we can say per 1 photon. So we know then that the number of photons can then equal the energy of the pulse divided by the energy of 1 single photon. All right, so the energy of the pulse, 3.85 millijoules. This is why I went ahead and converted it. 3.7, I did it again, 36 times 10 to the negative 16th millijoules. And these will cancel out. We should be left with nothing but a number. So let's take 3.85 divided by that calculation there. So I got 1.03 times 10 to the 16th. And this is a number we're counting. What are we counting? We're counting photons. So there's the answer.